Assalamu alaikum viewers, please like, share and subscribe this channel. Links of PDF files used in this video are given in description. So today's lecture is part 4 of our topic about composition of atmosphere. In the first portion of this lecture we have discussed the origin and concentration of major gases like nitrogen, oxygen, carbon dioxide and argon, whereas in this lecture we will discuss the minor gaseous constituents such as methane, ozone, dust particles, aerosols, etc. Methane is also a greenhouse gas which absorbs the radiation and causes more temperature of the air. Paddy cultivation also generates methane in the air. It is also produced from the wetlands and waterlogged soils and released in the atmosphere. Fossil fuel is also source to release of methane in the atmosphere. Its amount in the atmosphere is variable. The numerous sources of methane can be seen in this figure. So this diagram explains the major methane sources in the atmosphere with respect to their concentration. So the blue portion is the natural emissions, whereas the yellow portion is the anthropogenic or human made emissions. So in the form of ocean, in the form of methane hydrates, it is present in 3%. In the form of termites, it is present in concentration of 4%, whereas it wetlands and waterlogged areas it is present in 22%. Whereas by anthropogenic emissions through coal and oil mining and by natural gas it is emitted by 19%. Through fermentation it is emitted by 16%, then rice cultivation by 12%. Similarly 8% by biomass burning, 6% by landfills. Sewage treatment produces 5% of methane, whereas animal waste produce similarly 5% of methane in the atmosphere. The following diagram describes the annual increase in the atmosphere. As we are seeing that this is the data from 1983 year to 1993 and it is increasing every year, and here on y-axis the concentration of methane is, and it is given in parts per billion. So this is a variable gas in small but recently increasing concentrations released to the atmosphere through fossil fuel activities, livestock digestion and agriculture cultivation, especially rice. As a very effective absorber of terrestrial radiation, it plays an active role in the near surface warming. So it is a very important greenhouse gas and it is also considered to be responsible for overall global warming issue. So ozone's concentration lays in a belt between the heights of 15 to 50 km of atmosphere. Instead of normal 2 atoms of oxygen, ozone has 3 atoms of oxygen formed together donated by O3. It is found when atmospheric oxygen molecules are broken by ultraviolet solar radiations. It may even be found at a time of electrical discharge during thunderstorms. So this slide describes the stratospheric ozone production. So in the first step, this is the oxygen molecule and here comes the ultraviolet radiations from the sunlight. These radiations are so much energetic that they break the oxygen molecule, and in this way oxygen is converted into oxygen atoms with free radicals. In the next step, these oxygen containing free radicals react with further oxygen molecules to form O3. So the overall reaction for ozone production has been explained in this slide. This gas is also termed as variable as its formation and disintegration is dependent upon numerous activities. It may even be formed at a time of electrical discharge during thunderstorms. Though ozone is very less in quantity, like 0.00006%, this thin layer is very significant for the survival of living world as it absorbs the dangerous ultraviolet rays and protects the earth. So as we have previously discussed that there are 2 types of ozone, stratospheric ozone and tropospheric ozone. Stratospheric ozone is called as good ozone as it is the filter of harmful radiations that are coming from the sun. Those radiations are called as UV radiations. These are skin cancer causing radiations. Similarly, the ozone produced at troposphere is called as bad ozone because it produces so much toxic substances that are cancerous to human health. So in this way the stratospheric ozone is produced and it protects the earth from solar radiations that are mainly containing the UV radiations. Some other gases are extremely less in quantity and they are termed as trace gases. Those include ammonia, carbon monoxide, sulfur dioxide, nitrogen dioxide, nitrous oxide, and sulfur hexafluoride. In the beginning, when the atmosphere was in the developing stage, only a small fraction of water was present in the form of water vapors, and that was injected into the atmosphere during volcanic eruptions. So, most of that water vapor was condensed into clouds and rains, and then these continuous rains gave rise to oceans. The concentration of water vapor in the atmosphere was then substantially reduced. This diagram explains the water cycle. So here the majority of the water is in the oceans and it is approximately 97% is the percentage of mass of this hydrosphere. So from this ocean majority of the water is by undergoing evaporation is condensed into clouds and then these clouds condensed to form the precipitation. Now this precipitation is of two types, wet precipitation and dry precipitation. Wet precipitation is also called as rain, whereas dry precipitation is called as ice or snow. Then the ice or snow melts from the mountains or the northern poles of this earth and then it produces the fresh water. Then this fresh water is actually in two proportions. One type of fresh water is underground and this underground water is produced by percolation from the ponds and streams and rivers. This fresh water in lakes and rivers is about 0.02% of the total mass of hydrosphere, whereas in the ice the water is stored about 2.54%, whereas the fresh water in lakes and rivers that is in traveling motion is only about 0.02, whereas the underground water is actually 0.6%, whereas the water in this atmosphere is about 0.01% of the total atmosphere. So the water from these mountain areas is collected by rivers into these ponds, streams, and then from these ponds, streams, and rivers it is percolated to form the underground water. This underground water is absorbed by various plants and is used for agriculture activities and for domestic purposes, whereas the water which is present in the form of lakes and rivers and then the all type of water is ultimately deposited into the ocean again, and from ocean the evaporation starts, and in this way the whole cycle starts again. Although water vapor is small in amount, but it is one of the most important part of atmosphere with respect to the distribution of vegetation and life. Water vapor exists all the time in the atmosphere, but with varying degree of amount depending upon the season, like temperature conditions and the supply of water for evaporation and evapotranspiration. Air is hardly completely dry. In summer, the water holding capacity of the air is large as the temperature is high, while in winter it is low. Availability of sufficient amount of water on the earth's surface or water body in the area witness great vapor, while less availability or of avoidance of the same show low vapor pressure. Water is mainly found in the troposphere portion of the atmosphere and its concentration is in the lower level. About 90% of the total vapors lay below 6 km. It is estimated that about 50% is within the 2 km of the height. Water plays important and vital role in keeping the earth warm as it is also having a greenhouse characteristics. So it also contributes towards global warming. A huge amount of dust particles are also available in the lower layer of atmosphere in a suspended form. These dust particles are solid substances generated from various sources and being carried by winds. Greater velocity wind has greater amount of dust particles. It is not only a matter of suspended solid particles, they are transported to great distances as well. They vary widely in sizes. They may be big size, suspended only when the drafting ability of the wind is great, but settle swiftly when the carrying capacity of the wind is reduced. You may have observed yourself too during storms. Huge number of microscopic dust particles are suspended even in completely calm air. Dust particles are variable and it is more during dry seasons as the soils are loose and easily carried by winds. But reverse is the case when it is the rainy season when they are settled and compacted. Over the globe, it is less in equatorial and polar areas while more in subtropical hot desert areas. Minute dust particles are found several kilometers above the surface while the core sized particles are abundant near the surface. Microscopic particles are nuclei for condensation and precipitation and they have a great importance in this respect. Aerosols are extremely fine sized solid particles or liquid droplets which continue to be suspended form in gas for very long time. They could be seen when their concentration is more, otherwise they are invisible. Aerosols themselves are non-gaseous microscopic substances released in the atmosphere from various sources. These include natural and human created sources. They could be pollen, minute earth dust, sea salt, carbon soot from the burning fuels, and then volcanic eruptions. Human activities also help the aerosols to enter the atmosphere. Their concentration is more over the industrial and urban areas. Burning of fossil fuels and generation of smoke also pumps the aerosol in the atmosphere. The aerosols are grouped into two categories like hygroscopic, which are moisture absorbing, and non-hygroscopic, which not absorb any type of moisture. Hygroscopic aerosols form the nuclei for the condensation and in this way they help in the precipitation. So if we are seeing here that the dust particles which are pumped into the air by wind erosion, similarly the black carbon contents from the burning of fossil fuels, these also constitute the aerosols. Similarly the sea salt which is evaporated into the atmosphere also constitute the aerosol. So all these substances which are either liquid or solid and are non-gaseous form are all the aerosols. They contribute various types of things like these can scatter and absorb radiations. Similarly, in this way, by scattering and absorption of radiation, they have direct radiative effects. They have indirect radiative effects by formation of clouds and they contribute in the cloud formation because these aerosols provide the center on which the condensation of further water vapor occurs and in this way they also contribute in wet deposition. Some aerosols absorb the gases like sulfur dioxide, dimethyl sulfoxide, and these gases are absorbed on the surface of these aerosols and then they produce various types of chemical reactions and they produce various products and these products are secondary in nature. So from the above discussion, it is fairly obvious that our atmosphere is made up of innumerable minute molecules of several gases about which a discussion has been presented. Apart from that, several non-gaseous substances, there are also other parts and parcels of the things which have their own importance and significance. So all these things have their positive and negative contributions in the earth and definitely the human producing things are more negative in character as compared to the natural things. So this was all about the composition of atmosphere. I hope you have well understood this lecture, but if still you have confusion then let me know in the comment section. I will respond to your queries as soon as possible. Okay, thank you. Allah Hafiz.